Welcome, and thank you for joining Late Night Science. Tonight, as you let the weight of the day loosen its grip and you settle into the quiet, we will begin a journey together, one that flows gently between wonder and understanding. Can reality be explained? We will explore not only the universe outside you, but also the ways in which your own mind makes sense of it. Before we begin, I would love to know, where are you listening from tonight? Are you curled up in a small apartment with the hum of the city outside, or perhaps in a quiet countryside room where the stars gather silently overhead? Share your corner of the world in the comments. It is always a joy to see the many places where these quiet explorations reach. And if you find this video soothing, a gentle companion as you drift toward rest, please consider liking and subscribing so that these journeys can continue flowing out into the night. Now, let us take our first step into the mystery. Tonight, we ask a simple yet profound question. What does it mean for something to be real? You begin with what feels most certain, the ground beneath your feet, the air moving softly into your lungs, the familiar shapes of objects around you. Reality, at first glance, seems firm, obvious, and unquestionable. But physics teaches you to look closer, to peel back the layers of assumption, and to see that what feels solid is not always so steady. Your senses are like painters of a world, brushing colors, textures, and sounds into a picture you can navigate. You trust this painting because it is vivid and because it allows you to move through daily life with ease. But the painting is not the canvas beneath it. Your eyes do not show you atoms vibrating. Your ears do not capture the hum of molecules colliding. Your hands cannot feel the emptiness between particles. Your senses give you a version of reality, not the thing itself. This is where physics whispers gently. The world is stranger, subtler, and more fragile than it first appears. Consider the solidity of a chair. When you sit down, it supports you, feels resistant to your weight, feels strong. Yet inside, that chair is made mostly of empty space. The atoms that build its frame have dense, tiny cores, nuclei, surrounded by electrons that occupy vast regions compared to their size. If you could shrink down to see it, you would notice that most of what feels hard beneath you is emptiness, structured by invisible fields and forces. What you truly feel is not atoms pressing against atoms, but the invisible repulsion of electric charges, a delicate balance that masquerades as firmness. Reality, in this sense, is less like stone and more like a shimmering dance of patterns. Your body, too, is part of this dance. Every heartbeat, every thought, every breath is the result of particles that cannot be touched directly, only described in probabilities and interactions. And yet, you do not need to think about this dance to live. You move with confidence across the floor, drink a glass of water, or close your eyes to rest, trusting the world to remain steady even as it hides its strangeness. The philosopher Plato once spoke of a cave where people mistook shadows for reality itself. In some ways, physics suggests that you too may live among shadows, not false illusions, but partial glimpses, cast by a deeper structure beneath appearances. Your reality is both true and incomplete. This is not meant to unsettle you. Rather, it is an invitation to soften your grip on certainty. Think of a cloud drifting in the evening sky. From far away, it looks like a single solid shape. But as you move closer, you realize it is nothing but countless droplets suspended in air, each moving gently, each scattering light. The cloud is real, yet it is not what it first seemed. Reality itself may be like this, real in one sense, shifting and layered in another. As you rest into this thought, you might begin to ask, if reality is built from such unseen foundations, how do you know anything for certain? How do you separate what feels true from what is imagined? The answer is both simple and profound. You know through patterns. Your brain is a pattern finder, endlessly weaving fragments of perception into coherence. Physics, too, is a grand pattern finder, using mathematics to reveal the hidden rhythms of matter and motion. When you drop a stone into water and watch ripples spread, you see one such rhythm. When you notice the repeating cycle of day and night, you witness another. Behind the veil of appearances, patterns are the bridge between your perception and the universe's structure. But even patterns can surprise. Consider color. You see a leaf as green because your eyes are tuned to wavelengths of light reflected from it. Yet to a bee, the same leaf glows with ultraviolet hues invisible to you. Which is real, the green or the ultraviolet? Both, and neither. For color is not in the leaf itself, but in the interaction between light, matter, and perception. Reality is not a fixed picture on a wall. It is a conversation between the world and the mind that perceives it. This realization can feel dizzying, but it can also be soothing. Because if reality is not rigid, then you need not fear misunderstanding it. You are allowed to live within layers of truth, each appropriate for its scale. The physicist may say atoms are mostly empty space, but for you, the chair remains solid enough to rest on. Both truths coexist, each valid in its context. You might think of this as different kinds of music playing at once. To the ear, a gentle melody floats on the air. To the physicist, that melody is also pressure waves in air molecules, vibrating at specific frequencies. To the mathematician, it is a waveform describable by equations. Each description is real, each reveals something true, but none captures the whole of the music, and so, reality softens at its edges. It is not a single sharp line, but a collection of overlapping perspectives. The scientist, the philosopher, the artist, and the dreamer each see a different face of the same mystery. At this point in the night, your thoughts may slow into something quieter. You feel the pull of rest, like gravity drawing you down. But still, a gentle curiosity remains. If reality is layered and shifting, then how do you move through it with trust? Perhaps the answer lies not in solidity, but in continuity. The world may be built of unseen dances, but it dances with remarkable consistency. You trust that the sun will rise, that the floor will hold you, that water will quench thirst. These expectations are like a lullaby, repeating softly, giving rhythm to your days. Yet beneath the comfort of continuity, you may sense a question forming. If matter is not as solid as it seems, if perception is shaped by the mind, then what of time? Is time the most solid thing you know, the steady march of seconds, the turning of clocks? Or is it too one of those shadows on the wall of Plato's cave? The thought lingers gently as the chapter closes, leaving you with the soft uncertainty of a world that is both firm and fragile, both obvious and mysterious. And so, you turn from the question of reality's edges and drift toward the next. Wonder, the quiet, flowing river of time. You lie quietly now, with the echoes of our last thoughts still lingering. Reality itself is softer, more mysterious, more layered than it first appears. You have seen how the chair beneath you is not what it seems, how atoms are mostly empty, and how color is shaped as much by your perception as by the world outside. And as those questions begin to dissolve into the night, another one takes their place. Perhaps the most intimate question of all. What is time? Time is the current you live within. It is the river that carries you from birth to the present moment. And it is the horizon that always seems just ahead, beyond your reach. You measure it with clocks, calendars, and memories, and yet it remains slippery, impossible to hold in your hands. Tonight, as you rest, we will drift together along this quiet river, letting physics and philosophy offer their gentle lanterns of insight. When you close your eyes and remember yesterday, time feels like a straight path behind you. When you imagine, tomorrow time feels like another straight path, stretching ahead. And yet physics suggests something stranger, that past, present, and future may not be as separate as you think. Albert Einstein once wrote that the distinction between past, present, and future is only a stubbornly persistent illusion. What could he mean by this? To understand, imagine space itself, the vast arena where stars and galaxies exist. Just as space stretches in 3 dimensions, time might be seen as another dimension, woven into the very fabric of the universe. Together, space and time form space-time, a tapestry in which every event has its place, like threads crossing in a vast, cosmic loom. If this is so, then the present moment, the now you hold so dearly, may not be the only reality. The past still exists, resting in its own coordinates. The future, too, already waiting, though hidden from your experience. What you call the flow of time might be less like an arrow shot from a bow, and more like the way your consciousness moves through the chapters of a book already written. But in your daily life, time does not feel like a fixed dimension. It feels like movement. You wake, you live, you sleep, and the cycle repeats. Seconds tick by. Clocks remind you of schedules and responsibilities. The seasons shift, leaves fall, snow gathers, and blossoms return. If physics whispers that all times exist at once, why do you feel so powerfully the pull of forward motion? This is where the idea of time's arrow enters. Time appears to have a direction, from past to future, because of change, because of entropy. Entropy is the tendency of things to move from order to disorder, from neat arrangements to scattered ones. Think of a glass shattering. Once broken, it does not spontaneously reassemble. Eggs crack, but do not uncrack. Heat spreads out, but never concentrates on its own. This one-way unfolding gives you the sense that time itself is flowing forward. And yet, even here, physics offers a paradox. On the deepest level of particles and equations, many processes are reversible. The fundamental laws often work just as well going backward as they do forward. Only when systems grow large, when countless particles interact, does the arrow of time become so pronounced. So perhaps time's direction is not written into the core of reality, but into the way large patterns evolve. Think of a river. Stand close, and you see individual droplets moving in many directions, swirling and spinning unpredictably. Step back, and you notice the whole river flowing in one direction toward the sea. Time may be like this. On the microscopic level, motion is reversible, uncertain. But when you step back, when you see the collective pattern, the river flows one way, and you are always carried along. Now, consider how time behaves under Einstein's theory of relativity. The faster you move, the slower time flows for you compared to someone at rest. The stronger the gravity around you, the more time bends, stretching and slowing. Astronauts circling Earth experience time just a little differently than people on the ground. The difference is tiny but measurable. The faster you travel, the more dramatic the effect becomes. If you could fly near the speed of light, minutes for you might pass while decades unfold for those who remain behind. This is time dilation, the stretching of time itself. And it means that time is not universal. It does not tick equally for all. Instead, it is woven into motion, into gravity, into the fabric of space-time. Close your eyes and imagine 2 twins. One remains on Earth. The other boards a spacecraft and journeys close to light speed. When the traveling twin returns, perhaps only a few years older, the sibling on Earth has aged decades. Their timelines no longer align. What does this say about reality? It suggests that time is not absolute. It is relative, a fabric that stretches differently depending on where and how you move. At first, this may feel unsettling. If time is not the same for everyone, what becomes of your now? But perhaps the softness of this truth is not something to fear. Instead, it is a reminder that reality holds more flexibility than your daily clocks reveal. When you glance at a watch, it shows a neat, regular rhythm, tick after tick. Yet beneath those ticks lies a river whose currents bend and swirl, influenced by the gravity of stars and the speed of travelers. In this sense, time is not just a number. It is part of the living structure of the universe itself. But how does this connect to your experience of time, your sense of memory, anticipation, and presence? Neuroscience tells you that your brain is constantly weaving fragments together. Your memory knits the past into a story. Your imagination sketches the future. Your attention rests in the present moment, though never still for long. What you call now is perhaps a few seconds wide, stitched from the flow of sensations, perceptions, and thoughts. Time, as you live it, is not only physical, it is psychological, experiential. Here again, reality offers layers. There is time as measured by physics, by the ticking of atomic clocks, by the orbit of planets. And there is time as you feel it, sometimes fast, sometimes slow, depending on mood, attention, and state of rest. Hours can vanish in joy or stretch endlessly in boredom. Sleep erases whole stretches of it in silence. Perhaps time is both river and mirror, an external flow shaped by physics and an internal reflection shaped by consciousness. There are moments when these two times, the physical and the experiential, intertwine in surprising ways. Consider how light from distant stars travels for billions of years before reaching your eyes. When you gaze at a starry sky, you are seeing the past directly. Some of those stars may no longer exist, yet their light, their message, continues to arrive. The present moment you experience is layered with echoes of the past. And so, when you wonder about time, you are not only wondering about yourself, you are also wondering about the cosmos. Take a breath. Feel the gentle rise and fall of your chest. Each breath is a metronome, marking time not in seconds, but in the rhythms of your own body. The beating of your heart, the slow drift of sleep approaching. All are ways your body experiences time. In physics, time is often treated as a dimension, measurable and precise. But to you, in this moment, it feels more like a lullaby. Now consider the possibility that time may not even exist as an independent thing. Some physicists suggest that time is not fundamental at all, that it emerges from change, from relationships between events, from the way particles and energy interact. In this view, there is no ticking clock at the core of the universe. Instead, time is like a melody that appears when many instruments play together. Without change, without rhythm, time itself might vanish. This raises a haunting question. If time emerges, then from what does it emerge? And if reality can exist without time, what does that mean for your own life, built so deeply around its flow? But let us not rush. Tonight, you do not need to solve time. You only need to feel its softness, its mystery. The past has carried you. Here, the future is a mist, and the present moment is enough. As you rest within this thought, your mind may naturally drift toward another mystery, the stage upon which time unfolds. For time does not move alone. It is always intertwined with space. Together they form the great canvas of reality. And so, as one river carries you into sleep, another horizon appears. The question lingers gently, waiting for you. What is space, the vast stage on which existence itself performs? You have drifted with me through the soft edges of reality, where solidity dissolves into a dance of atoms, and through the flowing river of time, where moments bend and stretch with motion and memory. Tonight, you turn toward another mystery, one so vast it surrounds you completely, and yet so subtle you often forget it is there at all. That mystery is space. Space is the quiet backdrop against which all things appear. When you look at the night sky, you see stars, planets, and the glow of distant galaxies. But what you also see, what you sometimes forget to notice, is the darkness between them. That darkness is not nothing. It is not empty in the way an untouched room might feel empty. It is a vast stage, a fabric, a presence that allows everything else to exist. Close your eyes and imagine this. If every star were extinguished, if every planet were gone, if every atom of your own body vanished, something would remain. The stage itself would not collapse. Space would still stretch on, silent and immense, even without its actors. This raises a question that has stirred both physicists and philosophers for centuries. Is space a thing in itself, or is it simply the relationship between objects? For Isaac Newton, space was like a container, a great invisible box holding all, matter and motion. It was absolute, existing whether or not anything filled it. But for others, such as Gottfried Leibniz, space was not a thing at all. It was only a web of relations, the distance between objects, the arrangement of matter. Take away the objects, and there is nothing left to measure. Modern physics, with Einstein's theory of relativity, offers a kind of middle path. It suggests that space is not a passive stage, but an active fabric, something that can stretch, curve, ripple, and evolve. It is not merely a void, it is a player in the drama of the cosmos. Think of space like a great sheet of cloth. Place a heavy ball in the middle, and the sheet bends under its weight. Smaller balls roll toward the dip, not because they are pulled by an invisible force, but because the sheet itself has curved. In this way, Einstein described gravity, not as a pull from afar, but as the bending of space-time itself under the weight of matter. This means that space is not rigid. It is flexible, dynamic. Planets orbit stars because they follow the natural curves of space-time. Light from distant galaxies bends around clusters of matter because the very path of space is warped. Space listens to matter, and matter listens to space. Together, they weave the structure of the universe. Now, let us step deeper into the silence of space itself. To your eyes, space looks empty. But physics tells you that even in the most perfect vacuum, space is not truly void. Tiny fluctuations ripple constantly, particles and antiparticles appearing and vanishing in an endless quantum foam. What seems like nothing is alive with possibility. This restless background may even shape the expansion of the universe itself. Cosmologists speak of dark energy, a mysterious presence tied perhaps to the very nature of space, pushing galaxies apart, stretching the fabric ever faster. Imagine that, space itself as an engine, quietly accelerating the cosmos, carrying all matter outward like a tide you cannot see. For you, though, space is not only the grand cosmos, it is also intimate. It is the distance between you and the wall of your room, the space that holds the air you breathe, the invisible gaps that allow your body to move. Without space, you could not walk, stretch, or even breathe. Space is as close as the room around you and as far as the edge of the observable universe, and yet it feels intangible. You can touch a surface, you can see a star, but you cannot touch space itself. You can only move within it. It is like silence in music, something you cannot play directly, but without it, there would be no rhythm, no melody. Let us pause here and think of the night sky again. The distance to the nearest star beyond our sun is over 4 light years. That means light, the fastest traveler in the universe, takes 4 years just to reach us. Space is vast, almost unbearably vast. Yet, your mind, in an instant, can imagine the whole of it, leaping from here to distant galaxies in a single thought. This is the strange intimacy you share with space. Though it stretches beyond comprehension, it also lives inside your imagination. Scientists measure the universe's age at about 13.8 billion years. Because light travels at a finite speed, the farthest galaxies we see are also the oldest. When you look across the cosmos, you are not just looking into distance, you are looking into time. Space and time are inseparable, each woven into the other. The farther your gaze reaches into space, the deeper you see into the history of the universe. The night sky is a memory written in light. But let us return closer to the space within you. Your body is not solid in the way it feels. Between the nuclei of atoms and their electrons lies vast emptiness, much greater in proportion than the spaces between planets and stars. In a sense, you are mostly space. The solidity you feel is a kind of illusion, an effect of forces, not of filling. Space is not something outside you. It is within you, threaded through every particle that makes you whole. This brings us back to the question, what is space truly? Is it a container, a relation, a fabric, or a sea of possibilities? Perhaps it is all of these at once, depending on the scale you choose. To the physicist, it is measurable. To the philosopher, it is conceptual. To you, lying here in the quiet of night, it is the gentle distance that holds your breath, your room, your world, and your stars. Space is patient. It does not hurry. Galaxies drift for billions of years, carried on its expansion. Planets orbit for eons. Light itself takes its time crossing the cosmic sea. When you feel rushed in your own life, space reminds you of its scale, its calm. You are small, yes, but you are also part of this vast stage, woven into its fabric. Yet even here, mystery deepens. If space can bend and ripple, can it also end? Is there an edge to space, a boundary where it stops? Current understanding suggests that space may be infinite, stretching without end. Or perhaps it is finite yet unbounded, like the surface of a sphere. Walk far enough on Earth, and you circle back without ever finding an edge. Space itself may be like that, vast but whole, without a border. And if space has no edge, what does it mean to ask what lies beyond it? Perhaps that question is like asking what is north of the North Pole. The words stretch into meaninglessness. Beyond space may not be a place at all, but something outside your current ways of thinking. This is why space is not only scientific, but also deeply philosophical. It humbles you. It reminds you that your understanding is always partial, always provisional. You can measure, calculate, and describe, but the essence remains elusive, like silence, like emptiness, like sleep itself. Space is both presence and mystery. Take another breath. Feel the air fill your lungs, then leave again. The space within your chest expands and contracts, echoing the larger rhythms of the cosmos. Stars breathe too, burning, collapsing, and scattering their ashes into new clouds. Galaxies breathe, gathering and stretching across the expanding universe. The small and the large mirror one another, each held within space. And yet, what you call emptiness is not empty at all. It is a fullness of potential, a stage without which no drama could unfold. In sleep, you two drift into a kind of space, an inner space, a stillness that feels empty but gives rise to dreams. Space outside and space inside mirror each other, both silent, both creative. But as your thoughts slow, another question begins to form. If space is so vast, if it is the fabric on which existence is written, then what of the things that fill it? What of the matter that builds stars, planets, and you yourself? What is this illusion of solidity, this dance of particles that gives form to the stage? The night leaves you with this quiet invitation. You have wandered through the mystery of space, and now the path turns toward matter itself. You lie here, your body resting, your breath steady. You feel the surface beneath you, the firmness of the bed, the weight of the blanket. Your world feels solid, your body feels solid, the chair in the corner, the walls around you, the earth underfoot. All of it feels enduring, reliable, tangible. And yet, science whispers a quieter truth. Solidity is an illusion, a trick of perception shaped by the hidden structure of matter. Matter is everything you see, touch, and feel. It is the stuff of mountains and oceans, of stars and dust, of your own skin and bones. But beneath its surface, matter is not solid at all. It is mostly empty space, threaded with forces invisible to your senses. To understand this is to begin to see reality in a softer, stranger light. Imagine, if you can, shrinking down into the heart of matter. First, you move past the level of tissues, organs, and cells. You descend into the microscopic, where cells reveal their inner architecture. membranes, nuclei, mitochondria, humming with energy. Yet even here, you are not at the bottom. Go smaller still, into molecules, into atoms. An atom is the building block of all matter. Your body, the chair, the planet, all are made of atoms. Each atom holds a nucleus at its center, a tiny dense cluster of protons and neutrons, orbited by electrons that whirl in patterns like ghostly clouds. But what may surprise you is this. The nucleus is unimaginably small compared to the atom as a whole. If an atom were the size of a cathedral, its nucleus would be no larger than a grain of rice in the center. The rest is space. Vast, echoing emptiness. So why does matter feel solid? The answer lies in forces. Electrons may be tiny, but they resist one another through a fundamental law of physics. When your hand presses against a wall, the electrons in your skin repel the electrons in the wall. You never truly touch the wall. Instead, you are held apart by invisible forces, a cushion so firm your senses interpret it as contact. Solidity is not the filling of space, but the resistance of fields. Consider now the chair in your room. It looks strong, heavy, stable. Yet at the atomic level, it is a delicate lattice of atoms, vibrating constantly, bound together by electromagnetic forces. These bonds create structure, but the atoms themselves remain mostly empty. The chair you see is more emptiness than substance. Its solidity is a kind of mirage, built from forces rather than fullness. This understanding deepens when you move into the realm of particles. Inside every proton and neutron lie even smaller entities called quarks, bound by gluons in a ceaseless dance. The energy of these interactions is greater than the mass itself. In fact, most of the mass you call matter arises not from particles having weight, but from the energy of the fields that bind them. So matter is not simply stuff. It is a relationship, a dynamic balance between particles and forces, form and emptiness. What you perceive as solid is more like music than stone, vibrations, patterns, resonances shaping your reality. Now think of the stars. The same atoms that make your body were forged in their fiery cores. Hydrogen fused into helium, helium into heavier elements, until iron and beyond were born in the heart of dying stars. When those stars exploded, they scattered their matter into space, seeding the galaxy with the ingredients for life. Your bones contain calcium from ancient stars. The iron in your blood once shone in stellar furnaces. The solidity you feel is stardust shaped into form. This thought is comforting. The solidity of your body is both fragile and eternal. Fragile because it is built of empty space and fleeting interactions. Eternal because its atoms carry the history of stars, unchanged in essence since the dawn of the universe. Now, let us wander back into the everyday. You hold a glass of water. It feels cool, smooth, undeniably real. Yet the molecules of water are constantly shifting. Hydrogen bonds, forming and breaking in billionths of a second. The solidity of the glass, the liquidity of the water, the warmth of your skin, all of it is motion disguised as stillness. In this way, matter is like a dream, convincing, vivid, textured, but under scrutiny, it dissolves into patterns of emptiness and flow. There is also a subtler truth. Matter is not separate from energy. Albert Einstein showed this with his famous equation, E, mc2, which tells us mass and energy are two forms of the same essence. A particle of matter can be transformed into radiant energy, as in the heart of the sun, where mass disappears into light and warmth, and energy can condense into particles, creating matter from pure radiance. The solidity you rely upon is, at its core, frozen energy. Pause here and consider your own body again. You feel weight, texture, warmth. Yet what you call you is a shimmering interplay of particles and forces, energy and emptiness. Your body is not fixed. Atoms flow in and out with every breath, every sip of water, every meal. The matter of your body is borrowed from the world, always shifting, never permanent. In 7 years, almost every atom in your body will be replaced. You are a river of matter, flowing in the shape of a person. Philosophers have long pondered this. If your atoms change constantly, what makes you the same person from year to year? Perhaps identity does not lie in matter at all, but in pattern, in memory, in consciousness. Your body is not a static sculpture, but a living dance, held together by invisible threads of force, memory, and form. This brings us to the paradox of solidity. You depend on it to live, yet it is an illusion. The floor holds you, the air supports you, the earth carries you, all because of invisible interactions between particles. What you trust as firm is, in truth, mostly space. But this does not diminish its reality. The illusion works perfectly. You need solidity, and so you feel it. The illusion is your reality. Consider crystals, for example. Their beauty comes from the regular arrangement of atoms, repeating in perfect lattices. To your eye, they are gems of clarity and strength. 2. Physics. They are patterns in emptiness, vibrations locked into structure. Both views are true, two ways of seeing the same dance. Or consider the soft touch of fabric against your skin. You feel smoothness, texture, warmth. Yet these sensations arise from the way your nerves interpret atomic forces, translating emptiness into experience. Matter becomes touch, and touch becomes comfort. Even your thoughts rely on matter. Neurons in your brain fire signals, ions moving across membranes, molecules carrying messages. Yet each neuron is itself mostly space, its atoms held by invisible forces. Thought, memory, and dream, so intangible, arise from matter, which itself is intangible at its root. You are an illusion born of an illusion, yet what a profound and beautiful illusion it is. So let us rest here in wonder. Matter is not the hard, unyielding stuff you once believed. It is a symphony of particles, a dance of emptiness and force, a story written in the language of energy. You are part of that story, a momentary form shaped from ancient stardust, glowing briefly before returning to the flow. And just as matter carries you, it also connects you. The atoms in your body were once part of oceans, mountains, other lives. When you breathe out, the carbon you release may one day nourish a tree or drift into the lungs of another. Matter flows through you, not as possession, but as communion. Tonight, as you drift towards sleep, you can feel this truth more gently. Solidity is not permanence, it is presence, a fleeting arrangement that allows you to touch, to hold, to live. The illusion of solidity is the gift of the universe, a way for energy and emptiness to take form, if only for a while. And yet, another mystery waits in the quiet beyond. Matter changes, flows, dissolves, but time carries it all forward. The arrow of time gives shape to change, turning fleeting interactions into story, turning memory into meaning. So as you let your thoughts soften, you leave this chapter of matter, carried by the illusion of solidity, and prepare to follow the next thread, the mystery of time's direction. You feel the slow rhythm of your breath, in and out, like a tide returning again and again to the shore. In this rhythm, you notice something simple yet profound. Every breath you take belongs to this moment, not the one before, not the one after. Life seems to flow in one direction, carrying you forward. This one-way flow is the arrow of time, the silent current beneath every heartbeat, every memory, every step. When you look back at yesterday, it feels fixed, already written. When you look forward to tomorrow, it feels unwritten, a page waiting to be filled. The arrow of time separates what has already happened from what has yet to come. But what is this arrow really? Why does time feel like it moves in only one direction? Physics, philosophy, and your own experience each whisper answers, soft yet incomplete. Imagine for a moment the stillness of a glass of water. Place an ice cube within it. You know what will happen. The ice melts, the water grows cooler, the cube dissolves into liquid, but never the reverse. You never see the melted water leap back into solid ice, restoring itself neatly. This is one face of time's arrow. Things spread out, heat disperses, order tends to crumble into disorder. The word for this tendency is entropy. Entropy is the measure of disorder in a system. In every natural process, entropy increases. An egg breaks and scatters. It does not reassemble on its own. A hot cup of tea cools to room temperature. It does not grow hotter unless you intervene. Entropy is the reason time feels directional. It marks the distinction between past and future. But time itself, in the deepest equations of physics, does not always prefer a direction. If you could shrink yourself into the realm of particles, the laws that guide them work both forward and backward. A particle does not care whether time moves on or rewinds. The mathematics allow for both. It is only when countless particles come together in systems like teacups, stars, or living beings that direction appears. It is the scale of life that reveals the arrow. This makes time's arrow feel mysterious. It is not woven into the smallest threads of reality, but emerges when the threads intertwine into larger patterns. Like a melody emerging from single notes, the arrow of time emerges from the sum of countless interactions. You can feel this arrow in your own body. Your heart beats in one direction, never backward. Your memories accumulate behind you, not ahead of you. You age, cell by cell, moment by moment, moving forward. Yet deep within your body, in the molecular machinery of cells, the processes themselves could run either way in theory. It is only when seen together that their direction becomes irreversible. The arrow of time is also what gives meaning to story. Without it, there would be no before and after, no way to tell cause from effect. Imagine watching a film backwards. A shattered glass leaps from the floor back into a hand. A tree unburns itself into logs. You instantly sense something wrong. Your intuition knows the arrow. But here lies a question. If the arrow of time is tied to entropy, why did the universe begin in such a state of low entropy, such high order? The cosmos began in an extraordinary arrangement, smooth and balanced. As the universe expanded, entropy rose, giving us stars, galaxies, and life. Yet why the universe began ordered rather than chaotic remains one of physics' most profound mysteries. This puzzle reaches into your own experience. The reason you remember the past but not the future lies in entropy. The past was a state of lower disorder, etched into your brain as memory. The future has not yet unfolded. Entropy has not yet scattered its details. You carry the arrow of time inside your mind. Now let us consider clocks. You wear them on your wrist, hang them on your wall, glance at them on your phone. Clocks do not create time's arrow, but they measure its flow, dividing it into beats and seconds. Yet all these clocks, whether pendulums or quartz crystals, work by repeating cycles. Cycles are circular, not directional. It is entropy, not the tick, that gives time its sense of forwardness. Even the cosmos has its clocks. The earth spins, giving you day and night. It orbits the sun, giving you years. Stars burn their fuel, bright at first, then fading, ticking down across billions of years. Everywhere you look, clocks mark change, but the arrow emerges from the story those changes tell. There are moments when time's arrow feels fragile. Imagine drifting into a dreamless sleep. Hours may pass, yet when you wake, it feels as though no time has moved at all. Or think of a moment of deep focus when time seems to vanish. The arrow is still there, yet your mind softens its grip. Time is not only physical, but psychological, felt through perception as much as entropy. In physics, There are theories that suggest time itself may not be fundamental. Some physicists wonder whether time is an emergent property, like temperature, a quality that appears only when countless particles gather together. Just as a single molecule does not have a temperature, perhaps the universe in its deepest level does not have time, only timeless interactions. In this view, the arrow you feel is a story your mind writes upon a canvas that has no before or after. And yet, even if time is not fundamental, it remains deeply real for you. The arrow allows you to grow, to love, to learn. Without it, there would be no narrative, no memory, no future to anticipate. You live inside the arrow, even as physics questions its roots. Consider again the glass of water, the melting ice. The molecules dance, energy spreads, entropy increases. Now imagine this happening everywhere at once, in galaxies, in oceans, in your own body. The universe as a whole follows the arrow of time, always toward greater entropy. One day, far in the future, stars will burn out, galaxies will grow dark, and the cosmos will cool into stillness. This is called the heat death of the universe, the ultimate expression of entropy. But do not let this thought bring sorrow. The arrow of time gives your life its sweetness precisely because it is finite. Every moment is unrepeatable. Every breath is unique. The arrow carries you forward, but along the way, it gives you memory, meaning, and the possibility of wonder. Now close your eyes, if you wish, and imagine time as a river. You are floating gently, the water carrying you onward. You cannot paddle backward, only drift forward. Along the banks, you see memories, like stones left behind. Ahead lies possibility, unknown and shimmering. The river flows, and you are part of its flow. This is the arrow of time. And as you drift, another thought arises. If time is a river, what of space? If time flows forward, does space hold steady, or does it bend, stretch, and ripple too? The arrow of time points onward, but space and time are woven together. To follow the arrow deeper, you must explore the fabric that binds them. So let us leave this chapter here, resting in the current of the arrow. Time moves forward, entropy increases, memories accumulate, stories unfold. Yet beyond the arrow lies the greater question of what time is made of, how it is stitched into space, and whether this fabric itself can bend. You breathe slowly, feeling the weight of the present moment. The arrow of time still flows beneath you, carrying you forward. But now you begin to notice the stage upon which that arrow moves. Space and time, the twin dimensions in which you live your entire life, are so familiar you rarely pause to question them. You walk through space, you wait through time. They feel like separate things, one spread out around you, the other flowing ahead. Yet physics reveals they are not separate at all. They are threads of the same cloth, woven into a single fabric called space-time. Imagine spreading out a blanket across the floor, smooth, flat, stretched from edge to edge. This is space as you first picture it, an empty stage waiting to hold stars, planets, and galaxies. Now imagine pressing a heavy ball into the blanket. The fabric dips, bending under weight. Smaller balls placed nearby roll toward the dip, not because they are pulled by an invisible hand, but because the fabric itself curves and guides their motion. This simple image captures one of the most revolutionary ideas in science, Einstein's general theory of relativity. Mass bends space-time, and curved space-time tells matter how to move. Gravity is no longer a mysterious force acting across emptiness, but the shape of the fabric itself. You are held to the Earth not by invisible strings, but by the curve of space-time. Around your planet, consider the Sun at the center of the solar system. Planets orbit, not because they are tugged like stones on a rope, but because space-time dips around the Sun, and planets follow the curved paths laid before them. The Earth, in its yearly orbit, is tracing the geometry of space-time like a dancer, moving along lines etched into a floor. The moon follows Earth in the same way, locked into the subtle bend of the fabric. But this fabric is not static. When massive objects move, they send ripples through space-time itself. These ripples are called gravitational waves. First predicted by Einstein, they remained invisible for a century, until instruments sensitive enough finally detected them. Two black holes, spiraling into one another, sent out a tremor across the cosmos. Billions of years later, that tremor brushed through Earth, and humans felt the faint shiver of space-time. It is as though the universe itself is an ocean, and massive bodies send waves across its surface. You may wonder what this fabric is made of. The truth is, no one fully knows. Space and time feel like nothing at all. Emptiness, silence, absence. Yet they behave as something with shape, tension, and flexibility. To call it a fabric is only metaphor, but it helps you imagine. In reality, space and time may be the most fundamental qualities of existence, the backdrop on which everything else depends, and space itself is not as simple as it seems. You think of it as emptiness, a void. But modern physics suggests space may be seething with energy, even when empty of matter. Tiny fluctuations, called quantum fields, ripple invisibly. Virtual particles blink in and out of existence. The vacuum is not nothing, but a restless sea. The fabric of space-time hums even in silence. Time, too, is woven into this fabric. You cannot separate the where of events from the when. A lightning strike has both a location in space and a moment in time. Together, they form an event in space-time, and this leads to one of Einstein's most surprising discoveries. The flow of time is not the same everywhere. Time bends, stretches, and slows depending on how space-time curves. Imagine standing on a mountain and looking down at a clock in the valley. Because the clock in the valley sits deeper in Earth's gravity, it ticks more slowly than your clock above. The difference is tiny, invisible to daily life, but measurable with precise instruments. Time itself is shaped by gravity. Similarly, when you travel at high speed, time dilates, stretching so that you age more slowly than those left behind. Astronauts aboard the International Space Station experience this faintly. Their clocks tick just a bit differently than clocks on Earth. This bending of time is called time dilation, and it reveals that past, present, and future are not universal. There is no single now shared across the cosmos. Each observer carries their own slice of space-time, their own measure of reality. The fabric is flexible, relative, shifting with motion and mass. This can feel unsettling. You want time to be absolute, steady, the same for all. Yet the universe does not agree. Instead, reality is woven from perspectives, each tied to position and motion. In one sense, you live in your own private now, stitched into a greater fabric that holds countless overlapping nows together. The implications stretch further still. If space-time is a fabric, what lies beyond it? Can it tear, fold, or end? Black holes may hold the answer. In their centers, gravity curves space-time so sharply it collapses into a singularity, a point where the fabric's smoothness breaks down. Here, your equations falter, and you glimpse the edges of knowledge. Some theories even suggest space-time could emerge from deeper principles, as though the fabric itself were woven from threads not yet seen. Pause here and notice the comfort of your breath. You exist within this fabric. Every heartbeat, every memory, every star above you, all are patterns in space-time. You move through it as naturally as a fish moves through water, unaware of the medium that holds you. To reflect upon it is to feel a gentle awe, as if realizing that the ground beneath your feet is not merely Earth, but part of something vaster. The fabric of space-time is also expanding. Galaxies drift apart, not because they move through space, but because space itself stretches between them. Imagine dots on a balloon as it inflates. Each dot grows farther from the others, not because they crawl away, but because the surface itself grows. So it is with galaxies. the universe expands, carrying them apart. The fabric does not sit still. It swells, evolving with time. What then is the true nature of this fabric? Some physicists wonder if it is continuous, smooth, at every scale. Others suspect it is granular, like pixels in an image, built from indivisible units too small to see. This is the search for quantum gravity, a theory to unite the smooth curves of relativity with the jittering dance of quantum mechanics. In this search lies one of the greatest frontiers of physics, but you do not need to solve this frontier to rest in its wonder. Tonight, it is enough to know that space and time are not rigid, not absolute, but living fabric. They bend under weight, ripple with movement, stretch with expansion, and slow the ticking of clocks. They cradle your body, your life, your planet. They connect you to the galaxies, the black holes, the birth and fate of the cosmos itself. Now, close your eyes to imagine space-time as a vast star-strewn cloth. You lie upon it like a traveller upon a tapestry, woven into its patterns. Beneath you, the fabric bends under Earth's weight, holding you close. Around you, it ripples with distant collisions. Above you, it stretches, carrying galaxies away. You are not separate from it, but part of the weave. Your breath is one thread, your heartbeat another. And yet, within this fabric lies a deeper puzzle. The grand curves of space-time explain gravity, but they cannot explain the restless dance of particles. To understand matter at its smallest scales, you must enter another realm, the world of the quantum. Here, certainty dissolves, probability reigns, and reality itself becomes elusive. So as you rest in the fabric of space and time, let your curiosity drift ahead. What happens when you zoom into the smallest threads, where the fabric frays into shimmering possibilities? What secrets wait in the quantum mist that underlies all things? You lie still, breathing softly, as though floating on the calm surface of a quiet sea. The fabric of space and time cradles you, steady and vast. Yet tonight, your mind drifts downward, deeper than fabric, deeper than galaxies, toward the hidden threads from which the universe is woven. You're entering the quantum realm, a place so strange and delicate that even words tremble to describe it. Here the familiar rules of reality no longer hold. The ground beneath your feet becomes uncertain. A particle can be in many places at once, and certainty gives way to probabilities. Like a dream where walls shimmer and boundaries dissolve, the quantum world is not only the smallest scale of nature, it is also its most mysterious. Imagine shrinking yourself down, smaller than a grain of dust, smaller than an atom. You pass through shells of electrons, tiny clouds buzzing with energy. You move past the nucleus, where protons and neutrons huddle tightly together. And then, even smaller, you glimpse quarks, vibrating like notes in a hidden symphony. At this scale, your intuition falters. Objects are no longer solid. They blur, spread out, and behave like waves. An electron, for example, does not move like a marble rolling on a floor. Instead, it unfolds like ripples on water, spreading until an observation pins it down. This strange duality, particles behaving like both particles and waves, is at the heart of quantum mechanics. One of its most famous demonstrations is the double-slit experiment. Picture a beam of electrons fired at a screen with two narrow openings. If you do not look, the electrons behave like waves, interfering with themselves, creating patterns of light and dark. But the moment you observe them, they collapse into particles, each choosing a single path. Observation changes reality. You pause here, letting that truth settle gently. To watch is to shape. To measure is to decide. The universe, it seems, does not reveal itself fully until you lean in to ask. The uncertainty principle deepens this mystery. It tells you that some pairs of properties, like position and momentum, cannot both be known with perfect precision. The more clearly you see one, the blurrier the other becomes. Nature, at its core, is not a clockwork machine, but a symphony of uncertainties. And yet, out of these uncertainties, Stable matter forms. Atoms arrange themselves into molecules, molecules into cells, cells into bodies. You, lying here now, are proof that harmony can rise from uncertainty, that order can emerge from the restless dance beneath. Another quantum mystery is entanglement. Imagine two particles born together, like twins separated across the universe. No matter how far apart they travel, across rooms, across galaxies, their states remain linked. Change one, and the other changes instantly, as though distance is irrelevant. Einstein called it spooky action at a distance, a phrase that captures both wonder and unease. Entanglement challenges your idea of separateness. It suggests that the universe is deeply connected, that particles, once linked, carry echoes of each other forever. Some scientists dream of using this connection for quantum communication, sending information in ways classical wires and waves cannot match. Others see in it a whisper of something more profound, that reality itself may be less about parts, more about wholeness. Quantum mechanics is also the foundation of modern technology. The chips in your phone, the lasers in your devices, the MRI machines in hospitals, all rely on quantum principles. What began as strange puzzles in dusty lecture halls now guides the tools of your daily life. The mysterious has become practical, though its essence remains elusive. But perhaps the greatest enigma is the role of consciousness. Why does observation seem to matter? Why does the act of measuring collapse possibilities into outcomes? Some interpret this as a sign that mind and matter are entangled at the deepest level. Others argue the mystery is not about consciousness itself, but about how systems interact. Still, the question lingers. If reality is a cloud of possibilities, what anchors it to the world you experience? Pause for a moment. Feel your body resting on the fabric of space-time. Your mind touches the edge of this mystery. You are both observer and participant, both wave and particle in your own way. Your choices ripple outward. Your attention shapes your experience. Just as the quantum world waits for observation, your own life unfolds with each moment of awareness. Quantum mechanics also introduces the idea of superposition. This is the notion that a particle can exist in multiple states at once, like being here and there simultaneously, until measured. To illustrate, imagine Schrödinger's famous thought experiment, a cat placed in a box with a quantum device that may or may not release poison. Until you look, the cat exists in a superposition, both alive and not alive. Only observation resolves the ambiguity. Though unsettling, superposition is not just a thought experiment, it is real. Physicists have placed atoms, even molecules, into superposed states, balancing on the edge of possibility. At small scales, reality is not fixed but fluid, a shimmer of maybes. And yet, when you zoom out to your everyday life, the strangeness fades. A cup of tea does not exist in two states at once. A book does not dissolve into probabilities. Somehow, the quantum fog clears into the stable world you know. This transition from quantum uncertainty to classical certainty is itself a great mystery, called the measurement problem. How does the wave of probabilities collapse into a single reality? Scientists do not yet agree. Some theories suggest hidden variables. Others propose many worlds, each possibility realized in a branching universe. In one branch, the cat lives. In another, it does not. You exist in countless versions, each walking a different path. Whether this is true or not, the idea stretches the imagination, hinting at a multiverse woven into the very logic of quantum law. And still, deeper mysteries remain. What is the quantum field? The stage on which particles arise? Why does energy fluctuate in empty space? Could space-time itself emerge from entanglement, as though the fabric of reality is stitched together by quantum threads? The search for answers continues, but tonight you need not solve them. Instead, you can rest in the beauty of not knowing. The mystery itself is calming, like listening to waves whose depths you cannot see. Consider this: the universe you experience, the warmth of your skin, the breath in your chest, the stars in the night sky. is built from this strange foundation. Certainty rests upon uncertainty. Solidity rises from vibration. Your very body is a harmony of probabilities, collapsing into form with each instant. Close your eyes and picture the quantum world as a shimmering ocean, endless and subtle. Particles are like ripples, rising and fading. Entangled twins sparkle across its surface, linked beyond distance. Superpositions hum softly, like chords unresolved. You float upon this ocean, both part of it and witness to it, rocked by its gentle uncertainties. And now your thoughts begin to soften. You see that quantum mysteries are not only puzzles for scientists, but invitations for reflection. They remind you that reality is richer than it appears, that certainty is not always necessary, that wonder can thrive in uncertainty. As you drift further into rest, let this mystery cradle you. Let uncertainty feel like comfort, possibility like a lullaby. Because beyond the quantum lies another great puzzle. How can these tiny, uncertain particles build something as vast and ordered as the cosmos? How does the dance of probabilities give rise to galaxies, stars, and the arrow of time itself? That question leads you onward toward the next chapter, where the story shifts from the smallest scales to the largest. You will rise from the quantum ocean and look outward again, toward the origins of the universe itself. You rest quietly, still floating in the soft echoes of the quantum world, a place where particles shimmer between possibilities, where uncertainty sings like a lullaby, where everything that is waits to be noticed. From that shimmering sea of probabilities, your thoughts now rise upward, stretching outward, expanding as though carried on a gentle breath. And with that breath, you drift to the beginning, the earliest moment of all, the place where the universe itself was born. The birth of the universe is not something you can see directly. There were no eyes to witness it, no minds to record it. Yet, like archaeologists of the cosmos, scientists gather traces left behind, ancient light, patterns of matter, faint ripples in space-time. These traces whisper of a beginning, a singular moment of extraordinary expansion. It is called the Big Bang. You might imagine it as an explosion, but it is quieter, gentler, and stranger than that. It is not space exploding into something else. It is space itself, stretching, carrying matter and energy along with it. Not a fireball in the darkness, but darkness itself, blooming into light. At the very start, the universe was unimaginably small, hotter than any star, denser than any black hole. Time itself was just beginning. Space was just beginning. The rules of physics, the constants of nature, were finding their form. In that first instant, everything that would ever exist, every atom, every planet, every thought, was contained in a speck smaller than a grain of sand. Pause for a moment and let yourself imagine this. All the galaxies in the sky, all the oceans and mountains, all the laughter and sorrow, every song, every dream, all of it compressed into a single, radiant point. A point without before, because before had not yet been written. This is the mystery of the beginning. Not only the birth of matter, but the birth of time itself. The first tick of the cosmic clock. In that first instant, the universe expanded with astonishing speed, a process scientists call inflation. In less than the blink of an eye, the universe grew from smaller than an atom to larger than galaxies. Imagine a balloon inflating so rapidly you cannot see its motion, one moment tiny, the next immeasurable. Inflation stretched quantum ripples, those gentle fluctuations you visited in the last chapter across the cosmos. Those ripples became the seeds of galaxies, the faint fingerprints of randomness that blossomed into structure. Without those tiny whispers, the universe might have remained perfectly smooth, forever still. Instead, it grew lumpy, patterned, filled with possibility. As the universe expanded, it cooled. Within the first seconds, particles formed, quarks, gluons, electrons. They rushed and collided, sometimes annihilating, sometimes joining. Protons and neutrons were born, and with them, the building blocks of atoms. In the first 3 minutes, the first nuclei fused, hydrogen and helium, with traces of lithium. The universe had forged its earliest elements in a furnace hotter than imagination. Stars would not appear for hundreds of millions of years, yet the raw material of stars was already present, scattered in the newborn sky. The universe, at this point, was still opaque. Light could not travel freely. Imagine being underwater, where everything is hazy and hidden. The cosmos was like that, dense, glowing, filled with a fog of particles colliding. But then, after nearly 380,000 years, the fog cleared. Electrons settled into orbits around nuclei, forming stable atoms. At last, light was free to move. That first light still exists. It drifts around you even now, faint and cool, stretched by billions of years of expansion. It is called the cosmic microwave background, and scientists can see it with special instruments, an afterglow of the birth itself. When you look at that ancient light, you are looking at the baby picture of the universe. Let that thought soften you. As you lie here tonight, a gentle warmth in your chest, you are wrapped in the same light that filled the universe when it was young. A soft background glow everywhere, connecting every corner of the sky. As time passed, gravity went to work. Tiny clumps of matter, shaped by those quantum ripples, pulled more matter toward them. Slowly, like seeds growing in a vast field, galaxies began to take shape. Clouds of hydrogen collapsed, igniting into the first stars. Those stars fused hydrogen into helium, helium into heavier elements, carbon, oxygen, iron. When those first stars died, they scattered their elements back into space. Their explosions seeded the cosmos with the ingredients of planets, oceans, and life. You, breathing now, are made of atoms that were once inside ancient stars. The iron in your blood, the calcium in your bones, the oxygen filling your lungs, all forged in stellar furnaces that lit the early universe. But the story of the universe is not only about matter, it is also about mystery. Scientists have learned that most of what exists is invisible. Ordinary matter, the kind that makes stars, planets you, accounts for only a small fraction of the cosmos. The rest is hidden. Dark matter, unseen yet felt through its gravity, and dark energy, a force driving the expansion of the universe ever faster. So even as you gaze back to the birth, you find questions still unsolved. What is dark matter made of? Why does dark energy exist? Could the Big Bang itself have been born from something deeper, another universe, another cycle, another hidden law? For now, the answers remain beyond reach. And that is part of the wonder. The birth of the universe is not just a scientific theory. It is also an invitation to humility. To stand in awe of beginnings you cannot fully explain. To rest in the beauty of a question. Imagine yourself standing at that first moment, watching space unfold, watching time begin. There is no ground beneath your feet, no sky above your head, only a blooming light, spreading, cooling, shaping. You feel both, impossibly small and impossibly vast, for you are not separate from this moment. You are part of its unfolding, a continuation of its story. As your thoughts soften, you realize that the birth of the universe is also the birth of you. Without that first expansion, without those first stars, without the quiet work of billions of years, you would not be here, to wonder, to breathe, to listen. And so, you let the thought settle. You are a child of the Big Bang, carried in its echo, written in its light. Yet even as the universe was born, questions arise. Why does it exist at all? Why is there something, rather than nothing? Did the Big Bang have a cause, or is it the ultimate beginning? Some physicists imagine quantum fluctuations giving rise to universes the way bubbles rise in boiling water. Others imagine cycles of expansion and collapse, universes breathing in and out like lungs. These ideas remain unproven, yet they offer a gentle reminder. The birth of the universe may not be the final word. It may be part of a larger mystery, still unfolding. As you drift deeper toward rest, let that mystery feel soothing, not unsettling. You do not need to solve the beginning tonight. You need only feel its presence, the way dawn feels, even before the sun rises. The beginning is still here, woven into every atom around you, humming in the background of every moment. And as your breathing slows, you begin to sense a new question rising. If the universe was born, then how does it flow? How does time stretch? From that first instant to this very breath, what is the arrow that carries you forward moment by moment, never pausing, never reversing? That question will carry you gently into the next chapter, where the story of time itself begins to unfold. You are still resting in the glow of the universe's beginning, feeling its first light brushing gently against your imagination. The Big Bang has unfolded, stars have ignited, galaxies have bloomed, and yet one question lingers like a soft pulse beneath it all. How does the universe know which way to go? Why does time seem to flow forward, never back? This is the mystery of the arrow of time. In your daily life, you feel it constantly. You wake, you eat, you move, you rest. Each moment passes into memory, never to return. A broken cup does not reassemble itself. Smoke from a candle never gathers back into the wick. Time moves like a river with one direction, carrying you forward. And yet, the deepest laws of physics, the equations describing matter and energy, are symmetrical. They do not prefer forward or backward. They work both ways, like a film that could be played in either direction. So why, in your experience, does time march only one way? One answer lies in entropy. Entropy is the measure of disorder, of how many ways the pieces of a system can be arranged. A neat stack of cards has low entropy. A shuffled deck has high entropy. A warm cup of tea cooling on a table illustrates entropy perfectly. The molecules of heat spread outward, dispersing, mixing with the cooler air. Heat does not spontaneously gather back into the cup. The universe tends toward disorder, not because of malice or decay, but because disorder is simply more probable than order. The arrow of time, then, may be nothing more than the direction in which entropy increases. You pause to imagine this. The whole universe as a great unfolding deck of cards, shuffled more and more with every moment. At the beginning, just after the Big Bang, the universe was extraordinarily ordered. Matter and energy were smooth, dense, uniform. From that unlikely order, entropy has been rising ever since, giving direction to time, like a compass that always points forward. But entropy is not destruction, it is creativity. As the universe cooled, entropy allowed stars to form, planets to gather, and life to emerge. You, lying here tonight, are part of that flow. Your own body generates entropy every moment, dispersing energy as heat, exhaling warmth into the air. You are carried along by the same arrow as galaxies and stars. Still, there is something puzzling. If the fundamental laws of physics are time-symmetric, why did the universe begin in such a low entropy state? Why was the deck so neatly stacked at the start? Scientists do not yet know. Some suggest it was simply a condition of the Big Bang. Others imagine a deeper law we have not yet glimpsed, perhaps in ways you cannot yet understand. The birth of order was necessary for the birth of time itself. This question touches on memory too. Why can you remember the past but not the future? The answer may lie in entropy. Memories require physical storage, changes in your brain, traces left in neurons. Those traces accumulate only as entropy increases. The past is marked with records, the future is not yet written. And so your awareness follows the arrow, backward closed, forward open. Consider how comforting this is. The flow of time is not something separate from you. It lives in your body, in your thoughts, in your breath. The arrow of time is stitched into your memories, guiding your steps, carrying your story. Now picture yourself drifting outward into the cosmos again. You see galaxies spinning, stars burning, black holes swallowing light. All of them move in the same direction, entropy rising, the arrow of time pointing forward. The entire universe is part of this shared current. It is as though all things, from the smallest atom to the largest cluster of galaxies, are drifting together on a single great tide. And yet, not everything obeys the same sense of flow. At the quantum level, particles do not distinguish between past and future. Their equations unfold without direction. Time's arrow, it seems, emerges not from the small, but from the large, from the collective behavior of countless particles, their interactions summing to a trend that feels irreversible. This is a gentle paradox. The tiniest building blocks of reality have no sense of past or future, and yet your entire life depends on their collective agreement that time should flow forward. Entropy also gives rise to one of the most profound mysteries, the eventual fate of the universe. If entropy always increases, then one day, far in the future, all differences will even out. Stars will burn their fuel, galaxies will dim, black holes will evaporate, and the universe will drift toward heat death, a state of maximum entropy, where nothing more can happen. No patterns, no distinctions, no time as you know it. It is a sobering vision, yet also strangely peaceful. A universe at rest, its story complete, its arrow fully spent. But perhaps this is not the only possibility. Some scientists imagine a cyclical universe in which time's arrow might reset, entropy collapsing into order before expanding again. Others suggest hidden laws could prevent complete heat death, keeping change alive indefinitely. Still, for now, the second law of thermodynamics, the law of entropy, remains one of the most dependable truths of physics. Reflect on this. You are a witness of the arrow of time, riding along its current, yet also shaping its local flow. When you clean a messy desk, you impose order. When you create music, art, or even a thought, you carve structure into the rising tide of entropy. Life itself is a defiance of disorder, a delicate flame holding order for a brief span. You are not separate from entropy. You dance with it, resist it, and contribute to it all at once. Time also flows in rhythms. The rising and setting of the sun, the beating of your heart, the cycles of sleep and waking. These rhythms anchor you in the arrow of time, giving the infinite flow a human shape. As you listen, you can sense that rhythm, the slow inhale and exhale of your breath, marking moments, carrying you gently forward. And yet, deep in your mind, a lingering question forms. Is time itself real, or only a measure of change? Could the arrow of time be an illusion, a byproduct of your perspective? Some physicists argue that past, present, and future all coexist, that time does not flow, but simply is. In this view, your sense of movement is like a spotlight, illuminating one frame of an eternal film. Others insist time is fundamental, as real as space itself. The debate remains unresolved, an open doorway to wonder. As you sink deeper into rest, let that doorway comfort you. You do not need to resolve the nature of time tonight. You need only feel its presence, like a gentle current carrying you toward dreams. The arrow of time is both mystery and gift. It gives shape to your days, meaning to your memories, and direction to your life. And yet another thought emerges, soft as dawn. If the arrow of time is tied to entropy, then what does that say about the nature of order itself? How can structure, beauty, and meaning rise in a universe flowing toward disorder? How do patterns, like galaxies, like life, like consciousness, persist within the tide? This question leads you toward the next chapter, where the mystery of entropy becomes more than a law of disorder. It becomes a meditation on the balance between chaos and creation. You are still floating along the current of time, carried by the river of entropy. In the last chapter, you felt how disorder increases, how broken cups scatter and heat disperses, how the arrow of time points forward because the deck of the universe keeps shuffling. Yet tonight, you pause to notice something subtle. Even in this rising tide of disorder, there is beauty, there is structure, there is order that blossoms, persists, and even deepens. This is the paradox at the heart of entropy. The same law that drives disorder also gives rise to order. Think of the universe after the Big Bang. In its earliest moments, it was smooth, hot, uniform, so even that there were almost no distinctions at all. As it expanded and cooled, entropy increased. But that increase created room for galaxies, stars, and planets to form. Structure emerged because disorder grew. The very complexity that makes life possible is a child of entropy. Imagine pouring cream into coffee. At first you see two simple states, dark liquid and pale liquid. Stir, and entropy rises. The cream swirls, spreads, and eventually blends. At first glance, order seems lost. Yet notice the beauty of the process. Delicate patterns, spirals, fractals forming as the two mix. Order appears in the very act of disorder spreading, so it is with the universe. Entropy is not simply decay, it is transformation. Your body too lives in this balance. You eat food rich with chemical energy, and your body disperses that energy to keep you alive. Heat radiates from your skin, waste leaves your cells, entropy increases. And yet, within this flow, order arises. Tissues repair, thoughts form, memories crystallize. Life is a constant negotiation with entropy, borrowing energy from the environment to hold patterns together, to weave structure against the tide. You might think of life as a flame. A candle burns because wax molecules break apart, releasing energy into the air. Entropy increases, and yet the flame is ordered, structured, delicate. It exists only because of the flow of energy, only because entropy is rising. Your life, too, is a flame, a shape of order sustained by the river of disorder. Now expand this vision outward. Galaxies spin in graceful arms. Stars cluster into patterns. Rivers carve valleys. Snowflakes form intricate crystals, each one unique, each one structured. None of this defies entropy. Instead, it emerges from it. Complexity blooms at the edges of disorder. Physicist Ilya Prigogine once called such structures dissipative systems. They exist because they dissipate energy, because they increase entropy. Hurricanes, for example, are organized storms, spirals of wind and cloud. They are temporary, yet they exist precisely because they accelerate the spread of heat in the atmosphere. Life, too, is a dissipative system. Order born to assist entropy in its endless expansion. This is not a loss, but a rhythm. The universe is not marching toward chaos alone. It is also generating islands of order, fleeting yet profound. You, here tonight, are one such island, a conscious pattern, fragile but radiant. Consider how this changes the way you see disorder. A broken glass, a decaying leaf, a cooling star. These are not failures, but part of the greater balance. Without decay, there would be no growth. Without disorder, no creation. Entropy gives birth to the very conditions that allow beauty to arise. There is a story hidden in the stars that reminds you of this. When the first massive stars formed, they lived briefly, burning furiously. They collapsed, exploded, scattering elements into the cosmos. Their death was entropy's work, spreading matter, dispersing energy. Yet from that destruction came the elements of life: carbon, oxygen, iron. Out of entropy's hand came the possibility of oceans, forests, and breath. In the death of stars, order was seeded. In disorder, creation found its spark. This paradox is also alive in your mind. Neurons fire in vast networks, exchanging signals in patterns of staggering complexity. Each signal produces heat, waste, entropy. And yet, from that thermodynamic, cost comes thought, imagination, memory. Disorder fuels order. Your thoughts right now, drifting gently with these words, are a perfect example. They are ephemeral patterns, formed from countless interactions, dissolving even as they appear. Yet in their fragility lies their beauty. Entropy also guides the future of civilizations. Human society thrives by consuming energy, burning fuel, gathering sunlight, moving resources. Each act increases entropy globally, even while producing local order. Cities, languages, art, technology. Your very ability to listen, to learn, to dream is built on this balance. Civilization itself is a flame, structured but temporary, sustained by the dispersal of energy. And so, entropy is not your enemy. It is the pulse of the universe, the heartbeat beneath creation. Without it, nothing would happen. No star would shine, no tree would grow, no life would bloom. Yet, as with all mysteries, entropy carries questions. Why did the universe begin so ordered? Why does increasing entropy allow complexity to emerge, rather than dissolving everything into chaos immediately? Is there a deeper law guiding the balance between order and disorder? Some scientists suggest that order arises naturally at the edges of energy flow, that when systems are driven far from equilibrium, they generate structure to assist in dissipating energy. Others see in this a hint of something deeper, a principle, not yet fully named. Whatever the explanation, you can rest in the comfort that entropy is not only decline, it is also the shape of order, the reason beauty exists at all. Imagine drifting now through a forest in autumn. Leaves fall, decay, return to soil. At first, it feels like loss, but that decay feeds roots, nourishes seeds, ensures spring will return. Entropy is there in the falling leaves, and also in the new blossoms yet to come. The cycle is not destruction alone, it is transformation. You too are part of this cycle. Your body, your breath, your thoughts, all temporary, all beautiful, all part of the balance. One day, your atoms will return to the earth, to the air, to the stars. Disorder will reclaim them. Yet from that disorder, new order will rise. New forms, new lives, new beauty. Entropy ensures the story continues. As you sink deeper into rest, notice how this idea soothes rather than unsettles. You do not need to resist entropy. You need only dance with it, hold your flame while it burns, and trust that in the great unfolding, order and beauty will always find their place. Now, as your breathing slows, let your thoughts soften into one final reflection. If entropy shapes order, if the universe is a balance of decay and creation, then what does this say about meaning? Are meaning and purpose themselves patterns within this flow, structures arising briefly, then dissolving, yet leaving echoes? This gentle question carries you forward toward the next chapter, where the focus shifts from cosmic law to the intimate patterns of your own body. The story of the microbiome, the tiny universe within you, awaits. You have been gazing outward, across stars and galaxies, tracing the currents of entropy and the patterns of order that bloom from its flow. Tonight you turn inward. The cosmos does not end at the edge of the sky. Another universe lives inside. You, one so vast, so intricate that it rivals the stars in scale and mystery. This is the hidden universe of the microbiome, the countless tiny beings that live within your body, shaping not only your health, but perhaps even your thoughts. The numbers themselves are staggering. Trillions of microbes, bacteria, viruses, fungi, archaea, dwell inside you. Many live in your gut, but they also thrive on your skin, in your mouth, throughout your body. Together, they form ecosystems as complex as rainforests, with predators, allies, and endless exchanges of energy. If you counted their genes, you would find that they far outnumber your human genes, suggesting that in a very real way, you are not just one creature, but a community, a superorganism. Pause for a moment and picture this. You breathe slowly, and as your lungs rise and fall, a city of invisible life stirs inside you. Bacteria feed, divide, exchange messages. Some protect you from disease, others help you digest food, still others craft molecules that influence your brain. You are both host and habitat, a walking galaxy of microscopic stars. This idea is humbling. For so long, people thought of microbes only as enemies, as germs to be feared. And yes, some cause illness. But most are symbionts, partners in your existence. Without them, you could not survive. They are part of your identity, inseparable from who you are. Consider the simple act of eating. You take in food, but your body alone cannot break it all down. Microbes step in, digesting fibers, fermenting sugars, producing vitamins. They release short-chain fatty acids that nourish your cells, regulate your metabolism, and calm inflammation. Your meals are not yours alone. They are shared feasts with your microbial companions. And then comes the stranger truth. Your microbiome speaks to your mind. Scientists call it the gut-brain axis, a network of nerves, chemicals, and immune signals that connect the bacteria in your intestines to the neurons in your brain. When your microbes produce neurotransmitters like serotonin, dopamine, or GABA, they influence your mood. They may shape how you feel, how you think, even how you dream. Imagine that. Your quiet companions, too small to see, helping to weave the texture of your inner life. Anxiety, calm, joy, melancholy, all may be tuned by the symphony of microbes within. This connection invites reflection. Are your thoughts entirely yours, or are they shared? When you crave a certain food, is it your body calling, or is it your microbes whispering for what they need? When you feel peace after a nourishing meal, is it you alone, or the harmony of countless lives inside you? It is not just science, but metaphor too. You are never alone. You carry multitudes. Walt Whitman once wrote, "I am large, I contain multitudes." He may not have meant microbes, yet the truth fits. Your identity is plural. Your body is not a single being, but a chorus of life. Think of ecosystems you know, the coral reef, the rainforest, the meadow. Each thrives not because of one species alone, but because of balance, cooperation, competition, exchange. So it is with you. Health is not the absence of microbes, but the balance among them. When harmony reigns, you flourish. When imbalance arises, when helpful species dwindle or harmful ones bloom, disease may follow. Your skin glows with this hidden universe too. Every touch, every breath of air, every brush against the world shifts the community living upon you. These tiny organisms protect you, train your immune system, and even influence how wounds heal. You are porous, connected, alive with invisible exchanges. Pause again and breathe. Feel how your inhalation carries not just oxygen, but spores, particles, tiny forms of life. Feel how your exhalation releases them back. You are part of the cycle, both host and guest, shaping and being shaped by the microbial web. This hidden universe even travels with you across generations. When you were born, you inherited microbes from your mother through her body, her skin, her milk. You carry a lineage of unseen ancestors, passed down not only through genes but through ecosystems of life. When you touch others, when you share food, when you live in community, you exchange microbes. Invisible connections knit us all together, threads of life that bind humanity. Science is only beginning to map this terrain. We sequence DNA, we chart species, we trace molecules. Yet so much remains unknown. Why do certain microbial balances promote health while others tilt toward illness? How exactly do microbes shape memory, behavior, or creativity? Are they silent companions, or are they co-authors of your story? Speculation arises, as it always does in the face of mystery. Some imagine that personality itself might be influenced by microbes, that shifts in mood, temperament, or thought could be traced to the shifting tides of the microbiome. Others wonder if the microbiome holds keys to mental health, to depression, to resilience. The science is young, but the questions are vast. As you let these thoughts drift, notice how they soften your sense of self. You are not bounded only by skin. You are a symphony, a cloud, an ecosystem in motion. Your identity is distributed across trillions of tiny lives. Perhaps the boundary between self and world is less solid than you once believed. Consider again the stars. Galaxies emerge from clusters, their beauty formed by gravity's pull. Within you, ecosystems emerge from microbes, their beauty formed by exchange and balance. The pattern repeats, cosmos above, cosmos within. You are both astronomer and universe, both observer and galaxy. Entropy weaves into this picture too. The microbes within you thrive by consuming energy, breaking down molecules, dispersing matter. Their existence raises entropy, yet from that flow comes order, health, thought, consciousness itself. Just as stars burn to create life, microbes metabolize to sustain yours. Order at the edge of disorder again and again. If you listen closely, you might feel comfort here. You are not fragile in isolation, but resilient in community. Even at the smallest scale, you are supported by allies. Your health, your mind, your very sense of peace arises from countless tiny partnerships. And what does this mean for meaning itself? Perhaps it suggests that purpose is never solitary. Just as microbes and humans weave together, so too do individuals and societies, planets and stars. The story of life is not the story of one, but of many becoming one, again and again. Now, as your body grows heavier with rest, you can imagine yourself as a planet, rich with ecosystems, vibrant with life. Each breath is a tide. Each heartbeat is a sun. The microbes within you are galaxies, circling, glowing, whispering. You are a universe within a universe, and both are infinite. But this reflection, too, leads to a question. If identity is plural, if the self is shared, then what is consciousness? How does awareness arise from this multitude? Are you the conductor of the symphony? Or are you the music itself? This gentle question, unresolved and tender, carries you onward, toward the next chapter, where we will step beyond biology into the great puzzle of mind and self, and the mystery of how awareness glimmers in the dark. You have followed the trail of reality from the trembling of atoms to the pull of galaxies, from the arrow of entropy to the symphony of microbes inside your body. Now, you arrive at the most intimate mystery of all, the light behind the eyes, the spark you call consciousness. It is here, in the quiet chamber of awareness, that the universe seems to fold back upon itself. The stars look at themselves through your gaze. The cosmos becomes aware of its own existence in your mind. Pause, here, feel the stillness. Notice how your breath flows, how your thoughts drift like clouds across the sky of your mind. That very noticing, that gentle awareness of what is happening inside you, is consciousness. Simple, familiar, and yet unfathomably complex. Scientists and philosophers have wrestled with this mystery for centuries. What is consciousness? Is it a physical process, emerging from the firing of neurons, like flame from friction? Or is it something deeper, perhaps a property of the universe itself, woven into the fabric of reality, like space and time? You begin with what is known. The brain, that 3-pound organ resting quietly inside your skull, holds about 86 billion neurons. Each neuron is like a tiny tree, with branches reaching to thousands of others, passing signals in bursts of electricity and chemistry. Together they form trillions of connections, networks so vast that no supercomputer has yet matched their complexity. From these electrical storms, your thoughts arise, your memories flicker, your emotions bloom, your sense of self, the I that speaks silently in your mind, emerges. or so neuroscience tells us. But here is the riddle. How do physical signals give rise to experience? How does the firing of neurons translate into the taste of sweetness, the sound of music, the color, blue? This question is sometimes called the hard problem of consciousness, a phrase made famous by philosopher David Chalmers. We can trace the pathways of the brain. We can measure activity with scans. We can observe correlations between mind and matter. But the leap from activity to awareness remains unexplained. Imagine watching a symphony. You can study the instruments, you can map the notes, you can record the vibrations in the air. Yet none of this fully explains why music feels as it does, the ache, the joy, the soaring. Consciousness is like that. The difference between description and experience, between mechanism and meaning. This puzzle has given rise to many theories. Some propose that consciousness emerges from complexity itself, that when information is integrated in certain ways, awareness appears as a natural byproduct. Others suggest that consciousness is fundamental, that it does not arise from matter, but instead is as basic as energy or space, an ingredient of reality itself. Still others imagine the brain not as a generator of consciousness, but as a filter, narrowing a wider field of awareness into the focused stream you know as mind. Whichever view you hold, the mystery invites awe. As you listen, as you breathe, you're experiencing the most intimate and ordinary miracle. Being aware that you are aware. Think of sleep, that nightly dissolving of consciousness. Each night, awareness fades, and yet in dreams it flickers again, creating worlds as vivid as waking life. Then, at dawn, awareness returns, flowing back like light into a darkened room. What flips the switch? Where does consciousness go when you are not awake? These questions deepen the wonder. Even more striking is the idea that consciousness shapes reality itself. In physics, the act of observation collapses a quantum wave into a definite state. Before you look, a particle exists in many possibilities at once. After you look, it is here or there, not both. Some interpretations suggest that consciousness is entangled with this process, that awareness participates in shaping what is real. This may not mean that your mind creates the universe, but it does hint at a profound connection between observer and observed. You are not just a spectator of reality, you are woven into its unfolding. And what of the self, the I that feels continuous, that remembers yesterday and anticipates tomorrow? Neuroscience suggests that the self is not a single entity, but a construction, pieced together from memory, sensation, and story. Regions of the brain knit these fragments into a coherent narrative. In truth, the self may be more like a river than a stone, always flowing, always changing, yet appearing steady from moment to moment. This, too, is comforting in its own way. If the self is fluid, then identity is not a prison, but a process. You are not fixed, but unfolding. Consciousness allows you to witness this unfolding, to feel continuity even in change. Pause again. Feel your body resting. Notice the stream of thoughts, the quiet hum of awareness. You are the witness of it all, the stage on which sensations, emotions, and memories appear. Consciousness is not something you must achieve. It is already here, always present, the silent background of your life. Some traditions call this awareness the light behind the eyes. Others call it soul, spirit, or mind. Science may not use those terms, but it recognizes the phenomenon, the undeniable fact that you experience, that you know what it is like to be you. The implications ripple outward. If consciousness arises wherever complexity blooms, then might it exist beyond humans. Animals, with their eyes and minds, clearly share in awareness. But what of simpler creatures? The octopus, with its alien intelligence. The bee, with its collective hive mind. Even the single-celled organism, sensing and responding to its world. Where, if anywhere, does consciousness fade into non-awareness? The boundary is uncertain. And what of machines? As artificial intelligence grows more advanced, as circuits learn and adapt, the question arises, could consciousness flicker within silicon? Could awareness one day emerge in systems of code? And if so, how would we recognize it? Would we know if a machine were truly awake? These questions open into mystery, and yet they rest on the quiet wonder of your own experience. You do not need to solve them to feel the miracle. Each breath, each moment of noticing is enough. Consider again the stars. The same atoms that burn in the hearts of suns flow now through your brain, giving rise to thoughts, to dreams, to awareness. Consciousness is the cosmos reflecting upon itself. The universe, vast and ancient, has found a way to look inward, through you. In this light, your life is not small. You are not just a fleeting speck in endless space. You are the space made aware, the cosmos turned luminous. Even as entropy spreads, even as stars fade, in this moment, consciousness shines, fragile and bright. And yet, as you rest, you do not need to hold onto this light tightly. Awareness does not vanish when you sleep. It only softens, retreats, waits. You can trust it, like the rising of the sun. You can let go and drift, knowing that the light remains, even when unseen. So here, at the close of this journey, you can settle into peace. You have walked from atoms to galaxies, from entropy to mind. You have felt the unity of microbes, the fluidity of self, the vastness of awareness. And though the questions remain unanswered, perhaps that is the beauty. Consciousness does not need to be solved tonight. It only needs to be lived gently, moment by moment, as you drift into rest. When we began this journey, I welcomed you to Late Night Science. I asked where you were listening from, what corner of the world holds your quiet night. I asked if you might subscribe, if you might share in this unfolding path. And now, as the story closes, I thank you for joining. Thank you for carrying these questions in your heart. Thank you for letting curiosity accompany you into sleep. Perhaps tonight, the questions will weave into your dreams. Perhaps they will simply fade, leaving only calm. Either way, you are part of the story, the cosmos reflecting on itself, a spark of awareness in the vast dark. So let go. Let the questions rest. Let the light behind your eyes grow soft, like a candle gently dimming. Sleep, too, is a kind of knowing, a surrender into mystery. And as you drift, remember, reality may not be solved, but in this moment, it is lived. And that is enough.